Of mass 2 kilograms is allowed to slip down a smooth slope which is inclined at an angle A to the horizontal. Show that the acceleration of the particle is 1/5 g and that the normal reaction between the particle and the slope ground is of magnitude 4√6 g over 5. Okay, so this one is actually, I think, surprisingly easy. So you get yourself your slope like so, and you have a particle which is usually represented by a box like so, and this particle is going to slide down this plane. So what you're going to have to do next is angle A is the slope, so we're going to say that this angle A is opposite over hypotenuse 1 over 5. So it's 25 squared minus 1 squared is 24. It's going to be root 24 for A. So we have sine A equals 1/5, and cos A is going to equal root 24 over 5. Now that's done. Please remember, as for yesterday, your reaction force to the ground is always perpendicular to the slope of the ground you're on. Okay, so that means it's going directly up like so. Your weight, however, is going directly down. So weight will go directly down like this. Then you got to resolve it into its two components, horizontal and perpendicular to the plane, like so. So what is your weight for this one, guys? 2g, right? Because your weight is going directly down as 2g. This is angle A, same thing as the gravity triangle in projectiles. Then we got to figure out what this one is. This is going to be a 2g cos, what's it? 2g cos root 20, 2g cos A. What we know about cos A is that cos A is root 24 over 5. And then what I'll do there is I'll just multiply 2 by root 24 and then divide by 5. There's our 4√6 right there. 4√6 g over 5. So, see, this is actually a really easy question. 4√6 g, oh wait, 4√6 g and the 5's on the bottom. And what happens here is it says show that the acceleration of the particle is 1/5 g and show that the normal reaction between the particle and slope ground is of magnitude this here. Okay, so the two things I want you to look at is that the what goes up equals what goes down. So the R value, okay, put that underneath. What goes up perpendicular to the slope must be equal to what goes down perpendicular to the slope, because you notice that the block isn't sinking into the wedge, so they're perfectly balanced. So it means R equals 4√6 g over 5. That's proven. Okay. Show that the reaction force, that's done. Now next thing is prove that the acceleration of the particle is g over 5. Well, this here is g sine A. G sine A is the component of the weight that's driving it to be accelerated down the hill there. Okay, so 2g sine A. So 2g sine A is a fifth, so it's going to be 2g over 5. Now remember, mass times acceleration, which is going down the slope, is equal to your force going down the slope, which is 2g over 5. The mass of our object is 2a, so 2a going this direction equals 2g over 5. Divide by 2, a equals g over 5 ms to the minus 2. Okay, that's you done.